Hi, I'm John Michelson, the CTO of CA Technologies, and I'd like to introduce you to Service Virtualization. Solves the classic problem in composite application development, where developing and testing this is mostly about dealing with my constraints in my dependent systems. What do I mean by that? Here's my application, and here's an application that it talks to. It happens to be a legacy system. I have very little time on this legacy system. I get maybe 3 hours a week of access to the live system. That's a constraint. Here's my system of record. This data is constantly changing on me. Every time I run an application against it, I burn that data and I have to reset it. And resetting is not as simple as running a script because I don't have DBA type access to that data. I need to do performance testing of my application. But I have 2 transactions per second of capacity on the ERP system downstream. I need 200. I've got 2. And this one's great, isn't it? Third-party applications that cost me money every time I invoke them. In production, it's fine to have per transaction fees because the argument would be there's cost or revenue associated with the benefit of using that third party in production. Here, we sort of get this, let's not test that very much reaction because we're spending money every time we invoke that system. All 4 of these are a style of constraints. I can't do anything here until I solve for these constraints down here. And here's the problem. That would require more hardware than exists in the universe. So what are we going to do? We're going to do the same thing every other engineering discipline has done when they deal with composite architecture issues. We're going to use the concept of simulation. We're going to have software that listens to how this application interacts with these systems and builds, instead of a live environment, a virtual service environment so that I stand up my application live. But I don't need the access to the real legacy system. I have a virtual service that represents the behavior and data of the legacy system instead of the real one. Instead of the actual database of the system of record, I have a virtual service that represents stable data under my control. Instead of having a low capacity live landscape of the ERP system, I have simulation that runs at 2,000 or even 20,000 TPS without any trouble at all on not very much hardware. Or instead of spending money every time I invoke the third party, I spend no money to invoke my simulation. All of it is data stable. All of it is available to me 24/7. I can have as many of these as I can create virtual machines. I've just solved for the classic composite engineering problem, and I've done that in our world with software. Now, there's one other aspect I need to deal with. Again, go back to our simulation concept with other types of engineering. I not only have to solve for my downstream constraints, I don't want to have to wait for a bunch of iPhones to get the mobile app provisioned in order to see, does my application work? So I'm going to interact with a handful of handsets. I'm going to listen to how they behave, and I'm going to create a virtual consumer of my application so that I can essentially simulate the behavior expectations down and simulate the dependent systems below. What this allows me to do is completely isolate my application from all of the rest of the constrained applications that are around me. And this gives me the ability to do dev and test at least 30% faster with significantly higher quality with millions of dollars less in infrastructure costs than I would otherwise. That's the fundamental principle behind service virtualization. It takes the concept of simulation that we'd use with airplane wings, CPUs, and graphics cards, and applies it to software and composite application architectures.